Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be taking a look at Raspberry Pi's latest AI hat. It's based on the Hailo-10H and it's a great way, it's going to be the next great addition to your Homelab to be able to run large language models for very low power and a very small footprint. Before we get into it, be sure to smash that like button and subscribe if you haven't subscribed, because we're about to get extended. There we go. All right, so here's what we have today. So this is the Hailo-10H, and pretty much it's first party from Raspberry Pi. It's underneath this heatsink right here, and pretty much it's just a hat that sits on top, just gets power from the actual Raspberry Pi itself through the GPIO header, but it actually connects through PCIe to the Raspberry Pi. Now, the way I have it configured right here is I have the hat, the Pi, which it's a Pi 5 with 8 gigabytes of memory, and then on the bottom I actually have a USB 3 NVMe adapter. And the reason I have that is I want to run the actual OS off of the NVMe just for better performance, and to be honest, the USB 3 is more than fast enough opposed to trying to do like splitting it out or having any kind of I would say another hat that would make two PCIe connections that would potentially take away from the AI hat itself. So what I have in order to do that is I have a PoE hat and a different heatsink for the actual Pi 5. So I'm just going to disassemble this really quick and take you through exactly what I'm looking at here. And this is the stock cable that goes with it, that comes with it, which is 30 millimeters long. It's actually not going to be long enough. So first thing we're going to do is we're going to disconnect this cable right here. And I'm just going to unscrew the hat, and this will go right in between the two. But pretty much what we're going to do is we're going to be using Open Web UI, which is a really intuitive and I would say feature-rich, so to speak, web interface to be able to connect with Ollama models. So it works with a lot of stuff, but it has to be pre-compiled because again, this is just a just like the Hailo-8, which is what I did the last video on. It's still an int4 coprocessor. And we see that the hat itself, there's not a lot to it, but it does have 8 gigs of onboard RAM. I'll actually take off the heatsink just to show you. Hopefully without breaking it. Let's see. There we go. It's one. And it does require the heatsink in order to run, where the Hailo-8 did not require it. But in effect, what we're actually seeing here is we have the memory chip, which is right here, and then the Hailo itself, which is the larger chip right there. So, in effect, it's very similar form factor. If you remember the 8H or the 8, it did have a metal cap on it, and in this case, this wasn't the official hat. This was just straight from Hailo. And again, I paid for all of this myself. This is not sponsored or anything else like that. It's just something I thought was really cool. But this is what. There's a lesser version of this, which is the 13 tops version. This is the one that is not the L version. I think it's the also the H version. But this one is 40 tops, which is quite a bit more powerful and is, I would say, with the 8 gigs of RAM, quite capable of running a large language model at a really usable speed. And I'm just going to put this back on just before I get all of the heatsink pads dirty. But just presses in, right, and locks just like that. Now, I do want to show you something about this cable, just while I got it apart. And some hats will have, and this is an FFC cable, which is just for what it uses for PCIe. And in effect, what it has is it has the contacts on either side, so it flips it over. And for this, you see, anytime you see the black retention clip, it will always be away from the contacts. So there's two types, right? So, and I have both of them here, and these are the right length. But there's one with it on other side, but there's also, and this is called type B, and then there's the ones with it on the same side, and that's type A. So you don't want the type A, you do want the type B, and that will match. But it's got to be 40 millimeters long in this configuration that we're going to put it in. So first thing I'm going to do to get this all mounted up is carefully remove the actual header here, and then I also need to remove the heatsink as well. So realistically, it's probably going to be easier to just take off the bottom. I don't know if it's a, I forget what they call it, like a boot or something like that. It's not really a hat if it's underneath. That's not where I wear my hats, at least. So we'll have to see. But pretty much, there we go. It's all a buildup of these little studs and everything else like that, so they'll all come apart a little bit. But it's the same retention clip for the stock cooler that I have on here. But instead of the stock cooler, we're actually just going to be using the fan that's on the PoE hat itself. And that's going to be more than sufficient with the other heatsink, because to be honest, we're not going to be using the CPU much at all. And I'll show you that with the using top to be able to show you that it's minimal CPU. And it really is using the AI hat. But we'll get this disconnected here. Right, so I'm just squeezing the pins a little bit so it goes down, and then it just pops right out. So that's the hat removed, or that's the cooler, stock cooler removed. Just going to keep the heatsink transfer tape there. And we're not going to be using Wi-Fi in this, so it doesn't actually need to have cooler for that. But you can see this one's been attached once before. So this just goes down on top here and presses down in the same way the stock cooler does. And let me make sure it actually stays. There we go. Is that going to stay? Let's see. May need to finagle that a little bit. Let's see. Or did I put it on backwards? I put it on backwards. Oh my gosh. It'd be terrible if I broke this. It would defeat the whole purpose. So I'm going to put this on the right way. And the key thing is it shouldn't be covering the camera ports. All right. That's a lot better. but just press it down. And I should have known because it was sticking up in a weird way. Okay, so now, see that's sitting down flat. You know, it's making good contact with the both the RAM and the actual CPU itself. And it doesn't look like it's popping up, so I'm happy with that. I am going to pull off this header extender just because I need it for the top. Oh, and that's going to be so much easier said than done. Avert your eyes. Okay, so I got it. So now I'm going to put on the cooler. First thing I'm going to do is I'm going to plug in the actual fan. And I do have a parts list just in the description, as well as a GitHub link, just if you don't like all the talking and the demo. You can kind of skip ahead and try it yourself. For everything that we're going to do here, we're going to go through the GitHub that I prepared. So we're just going to press this down without crimping into the cable, hopefully. There we go. So now that's seated. And I'm going to use these additional standoffs to actually stand it high enough to be able to take the hat with the extender. And some of this is a little bit of a hodgepodge, but these are just standard 2.5mm standoffs. So. I'm not going too crazy with making it tight or anything else like that. It's not going to run away on me. And really, it's just going to be sitting in my home lab for me to be able to access remotely. So it's not even going to require any kind of real interaction once it's actually set up. Before I get too far into it, I'm just going to get this seated. Again, this is the Type B cable. So I'm going to place this into the PCIe header. Make sure it's seated nicely. Right, it's there, it's secure, it is centered. That's a key thing. All right, and now I'm going to put on the hat itself. So first thing, I got to put the extender, the pin extender. And the nice thing about this particular PoE hat from Waveshare is that it does pass through all of the pins. So it has all the ones that we need in order to be able to make this work. Some of the PoE hats do not do that, and it makes it a heck of a time to try and get it all connected. But you see it fits very nicely. I don't have a case for this, but you know what, that's okay. And then we'll just put in these screws on the top, secure this down. And that'll make it nice and solid so it's not going to start trying to break loose of its connections. And you see how exact the 40mm are. And I do have longer ones, like it came in a fun pack of all kinds of lengths and things like that. And to be honest, compared to the cost of the AI hat itself and the Raspberry Pi and everything, not very expensive. And the one advantage of this is that it still uses very little power, to where on a per watt basis, you get a lot of horsepower versus trying to use a CPU or even trying to use a standard GPU. So now what I'm going to do is I'm just going to bend this over a little bit, and I'm going to seat it in here. Right, and we see the contacts are facing up because the clip's on the bottom. So I'm going to pull out that clip, get it started in here. All right, make sure it's seated and centered. All right, and then clamp it in. And we'll find out when we start it up if it is actually making good contact, but it is secure. So at the end of the day, I'm happy with that. So this top part is all settled, and we see the fan has good ventilation in the middle. It's blowing straight down on the heatsink, which will vent out any heat to the side. So at the end of the day, it's not going to overheat as a function of that. And now with this is just a standard NVMe hat. It came from GeeekPi or something like that. Again, the parts list is in the description. And this one I chose in particular because it does have the USB 3, and it comes with the bottom USB 3 connector. So it goes on upside down like this. So these are facing the same direction. And I'm just going to use a few more standoffs, which will both hold this together firmly, so it's not going to start trying to put torque on the USB 3 connector, and also provide standoff so that way the NVMe gets proper cooling. Although there's not going to be that much load overall. But one of the nice things about the open web UI is that it'll actually let you change models on the fly. So you can have multiple users, it does have access control, things like that, but you can choose different models. And we're going to go through that on how you actually download them and make use of those different models. All right, and then now that we have it secure, we just plug it in like that, and we're pretty much ready to go. Now, one thing, I have a USB. I have a micro SD card that is pre-flashed with the latest Raspberry Pi OS. And I'm going to put that in order to boot from it, which will both allow us to get updates just in case we can't boot off of USB by default. You may need to do a firmware update to your Pi. I've already done that in this case, but it'll let us install it to the NVMe by using the Raspberry Pi imager. So I'm just going to connect it up right now. So I got a keyboard and mouse I'm connecting, and then video and power. And we can see there's power going to the AI hat as well as to the Pi itself. So let's switch over to KVM, and with any luck, we'll actually see output on the display. So right now we're booting off of the SD card. All right, so we've booted off of there. We do see some additional drives. I'm just going to switch over to be able to control it. And I'm not going to actually do any pre-configuration in here. I'm just going to go to the Raspberry Pi symbol on the top left, go to Accessories, and go to Raspberry Pi Imager. It's going to ask me for authentication. So just put in whatever authentication that you made for your actual Pi, or for the image that you installed on your SD card. Now, this is the latest version of the Raspberry Pi Imager as of the date of the stream, which is February 3rd. And pretty much, we're just going to choose Raspberry Pi 5, which is what we're installing this to. I mean, it's what it's running anyway, but we're going to choose the 64-bit Pi OS. And we're going to choose the NVMe. In this case, I'm using a 500 gig NVMe drive, but really you could use 128 gig NVMe. You could probably even use 64 gig. I mean, really, it just limits the amount of logs you're able to store as well as the number of models that you're able to store. All right, so we're going to do this. We're going to call it Hailo-10H-Dev. just because that's what I happen to name the SD card. In my case, capital city for US is Washington, D.C. My time zone is New York. Get all that set. And I'm going to use the username dev. And I'm going to give it a very secure password. Amazing. I'm not going to use Wi-Fi because I'm going to use hardwired Ethernet in this case. And I do find it easier with hardwired Ethernet just because that way, if you're going to use it as a server, the connection is going to be a bit more stable. But there's no reason you couldn't use it over Wi-Fi. You just have to give it a static IP address. And I'm going to enable SSH with password authentication just so it's easier to administrate. Again, this isn't going to be used over the public internet. I'm not sharing this with anybody outside of my local network, so that's perfectly fine. And I'm not going to use Raspberry Pi Connect. All right, it's giving me the final confirmation, and I'm just going to hit right. It's going to make me confirm that I understand this is going to blow away everything. I did actually already build it on that particular drive, so we're just going to blow it away just because we're not going to look at it. We're just going to rebuild it again. It's going to be amazing. So. Yeah, no. Oh, wow. I can't pronounce your username, but he said not having a case will be better for cooling, and that is 100% true. Realistically, I mean, I couldn't find a case that would actually fit this stack. Like, there's ones that maybe could have fit it, but it was just, I wasn't happy with the way the cases looked and everything else like that. Also, they tended to have solid sides, which is very problematic for trying to do any kind of any realistic cooling or processing. So for different applications, I do have cases on them, but in this particular case, I don't think it needs a case. So very good point. And sorry, I can't pronounce your username. Veluvalu Venkat. Veluvalu Venkat. There we go. I tried. Hopefully that's it. So thanks for the chat. So it's almost done writing. It's going to verify really quick, which should be a lot faster than the write cycle itself. Actually, the limiting factor in this is the SD card. But I think once it gets it finished, we'll be able to remove the SD card and go ahead and boot onto the NVMe. Perfect. So we're going to hit finish. I'm actually going to fully shut it down just so I can remove the card without it booting up to it again. In this particular case, I do have my default boot set to go to the SD card first. That way, if I do want to change things in the future like this, I don't have to go in and try and change those boot settings. All right, so the SD card has been removed. So it's an empty slot. It's just got the NVMe attached. I'm going to hit the power button. It's going to start blinking away. We'll go back over to the Pi. We see it goes to the default BIOS screen. And now it's going to boot after it warns me about the power supply, which is fine. We might need to add that to the actual drive itself. So what it's saying is that we need to add the USB max current enable equals 1 in the config because it doesn't have a 5 amp power supply. So technically it's only 4.5 amps, which is more than enough because we're not plugging in additional peripherals into this, but it may block us from actually doing it. And let's see, I think it's 4. No, it's going to make us do this. So 1 minute, we should have done this while we were there. So it's the USB max current enable. So I'm just going to put in the SD card again. and we'll try it. I could always cheat and just plug in an external power supply, but that defeats the whole purpose of having a PoE hat. And actually, let me just power cycle. Wait for it to come up. It's going to boot off of the SD card now as the default device. There it is. While it's happening, I'm just going to get a reference. Yeah, we'll do it together. Okay, so there's two options here for it. So it's rootfs or bootfs, right? So bootfs will have our user CFG. Again, we're doing this on the NVMe, so it's not the SD card that we're doing this on. Actually, was it command dot? Let's see. So it's config.txt, because again, we're not on Alpine Linux. I want to see if it has it already here as an option that we can just pull. No, of course not. So I'm just going to open up the browser really quick and just confirm, because my memory is not good enough for that. So it's all right. So I think I wrote it right. We're going to find out together. You know what? So we're going to go down here to the bottom where it says all. And we're going to do USB max power enable equals 1. And that's what it said to do when we tried to boot last. I'm just going to put a new line at the bottom, save it out, close it, and then we'll try and boot again. So let's do shutdown. I'm going to pull out the SD card once more, hit the boot button, which is a great addition. All right, so it's trying to boot. Hopefully we put it on the right partition. Fingers crossed. And what did I do? Max current enable. Is that what I wrote? USB max current enable. I don't think I did that. I did power. Shucks. So I put back in the SD card. Let's correct the typo. Oh no, what's it doing? 1 minute. Wait, I don't like what it's doing. Or did it just boot? Let's see. Did it work and I didn't give it enough time? But that's not a usual thing. So, but to be honest, I mean, there are other ways to override it, but we're going to make it to where it boots all on its own with no help. Oh, not command line. One below it. Config.txt. Max current enable. Okay. Hopefully now it just runs. Otherwise, I'm just going to bypass it and we'll figure it out. I'll update it in the notes later. Okay, shut down. SD card out. Power it up. It's reading off the drive. There we go. Okay, so that was it. USB max current enabled equals 1. It's now booting. It didn't present us that error. If it overheats, the fan will just kick on. But to be honest, it's quite a bit larger. It's got quite a bit more power than it actually says. I have had no problems with running the Raspberry Pi 5 off of this PoE hat. And it even has a 12-volt output rail if you didn't need to run 12-volt accessories. So what happened just a second ago is it just rebooted in order to expand the file system to max out the drive. So now it's actually showing up as the full drive itself. It's still going to complain about this, but to be honest, it's not going to restrict anything. So at this point, not worried about it. So let's go to the GitHub really quick, and I'll show you that. And give it a second because it's still doing tasks. My cat is trying to say hello. We'll see if she wants to come up here. You want to come up here? You want to say hello? You want to sit up here? Here, I'll turn on your camera. All right, so first time, obviously, logging into this. So at the end of the day, I'm going to give it a really secure password. It's just the key ring. And now we can go to github.com/extendedgreg. All right, and what's the matter? We'll go to repositories, and we see here Raspberry Pi Hailo-10. That is the one that we're going to be working off of here. So as we scroll down, we get into where we are, right? So Raspberry Pi, we're using the 8GB model. We have the Accelerator AI Hat, which is 40 tops. And then we have the active cooler. In this case, we're using the active PoE hat for that. And we're using Raspberry Pi OS Bookworm 64-bit. So first thing we're going to do, we're going to open up a terminal and we're going to start doing some updates. And nice thing about this is we could do copy and paste. So I'm just going to copy and paste the commands as we see them in order. So we're going to update by doing sudo apt update to update the repositories, and then doing the upgrade in order to actually do the upgrade. It'll prompt with the Y. Yes. And we're going to bring it up to the most current version in order to make sure that we're working with what the actual packages that we're going to install are expecting in terms of those particular packages themselves. Right? And pretty much, we're going to let that do its thing. And it goes pretty quick because, again, the NVMe is pretty quick and it's not bottlenecked by the CPU, really. So it zooms along, and to be honest, it's a lot better than the SD card. I know at some point they're probably going to do the upgraded SD cards that do PCIe natively in a future version of the Pi, I have no doubt. But they haven't quite gotten there yet, so that's still a bottleneck. And if you're just trying to use it regularly, so it's very nice that they added the NVMe capability through PCI. But because we want to use the PCI bus for something else, it's inelegant to share it. And this definitely benefits from using the full bandwidth at Gen 3 speeds. And that's actually going to be the next thing that we're going to do, is we're going to go into Raspi config to enable Gen 3 speeds. There we go. So we're going to do sudo raspi config. And in here, we're going to go to Advanced Options, PCIe Speed, and it says, would you like to enable Gen 3 speeds? Yes, we would. And that's all we have to update in here. So we're going to go to Finish, which will now take us, it'll ask us if we want to reboot, and the answer is yes. We definitely want to reboot. And the reboot's, again, very quick. It's just running through the NVMe, which is, again, very quick recovery time. Okay, so we're back. Let's give it a second here. I'm going to reopen up the browser. And we're just going to restore it, which you can't see because of the cat. I had a key going for the cat, but OBS has been giving me a lot of fun. So pretty much we're just stuck with a basic mask. So she wants to hang off the actual thing, but that's okay. So let's open back up a terminal and let's continue by installing the drivers. So next thing we're going to do is we're going to install the Hailo-10 all, which will give us all of the needed packages and drivers to be able to do it. So we'll paste that in. It only takes a second to actually do the installation. Confirm yes. Says it is doing things. Right? I mean, the mouse is still moving. It's still doing things. Or did it finish? Oh, it's still doing things, but I stopped it from scrolling. There it is. So now that it's done, let's actually make sure that we can see our PCIe Hailo chip. So we're going to copy that next line, which should give us a readout on what card we actually have. And we do see it here. It is the Hailo-10H. So it's showing up properly, and now we know that we can continue forward. It says control protocol version is 2, which is just the internal protocol for the Hailo. I don't believe it's a PCIe version. We could actually check that, but it'll work. It should be at Gen 3 speeds. I haven't had an issue with that. And now we're going to pretty much download and compile our models themselves. So we're going to install our dependencies. Same deal. Just going to paste this in. And what this is going to do is just pretty much make it so we can actually compile what we need to in order to be able to run everything. So now we're going to deal with our models and actually our model runtime, which is the Hailo Ollama script, or application, I should say, because it is compiled. So we're going to cd into our home directory. We're going to build all this through the home directory. Like it or not, you can change that if you want, but at the end of the day, the whole thing's based on that. So just, if you're going to try this for the first time, try it as it's written before you start reinventing the wheel. So we just cloned this particular repository, and you can go there and you can navigate it, all of that. It has quite a few options in terms of models, things like that. It gives you 5 by default that it'll download here, right? If we ls this directory, we see Halo Model Zoo Gen AI. That's what we just downloaded, and that's where our Git repository is. So next thing we're going to do is we're going to cd into it, and then we're going to make a directory called build, and then go into that directory. Right, now we see we are in we're not in the right directory. That may be an issue with my instructions, but cd Halo Model Zoo Gen AI, which it said didn't exist for some reason. Oh, I put dashes. It's supposed to be underscores. You see that? Give me 2 seconds. I'm going to fix that. Nobody's going to know. Nobody's going to know. So we're going to do Halo underscore. Probably mess that up somewhere else in this script as well. Oh, I definitely did. I copied it multiple times. All right, well, we'll live with that. So pretty much we're going to be doing cd to the build directory. So we'll do this next line right here. We're going to copy that. We're going to go paste it in. And now we're in the build directory, which is where we're supposed to be. So first thing we're going to do is we're going to do cmake. We're going to tell it that we want build type to be release, and we're going to do it from the previous directory, right? So if we do ls ... we see that it has a bunch of files. One of them is cmake lists and build and build, which is what we just made, you know, config docs, all of that stuff. So we're just going to be building. It's going to look at cmake lists, and it's going to build everything that it needs to. And this only takes a second. It's very quick, and it's done. The next one is not so quick. And we're going to be actually building the whole thing. And it's going to be building us the executables and everything else like that that we need in order to be able to run this. So we're still in the same directory, and we're going to do it. But we're going to do -- build dot, which is the local directory, and then -j4, which will use 4 threads to pretty much max the CPU since it's capable of 4 threads. So we'll start that running. It goes a lot faster with J4 versus doing it without J4. But yeah, it is something where it takes a second. But you'll see it zips along pretty quick. So hopefully everybody's enjoying the stream so far. I know Nala's enjoying it a lot, right? Right? And if you haven't seen it, I have another video about the Hailo-8, which goes into more detail about the background and kind of does a write-up about more information about AI in report form. That's also on the GitHub as well. But it includes kind of a visual example because the main difference with that particular AI accelerator was it didn't have any onboard RAM. So it had issues with large language models in particular, but apparently had no issues doing video processing. So you could use it for real-time video classification. So like if you wanted to identify certain things like animals, somebody was holding a bottle, a phone, etc. And we go through those examples in the previous video that's linked in the GitHub. But it was definitely something that I think for what a lot of use cases are outside of like home security or automation, I think it's definitely something where it's the Hailo-10 definitely has a lot more options. And supposedly you can even train your own models using it as well. Although I'm going to look into that. I had a lot of problems trying to train models for the 8, and I'm going to see how much more luck I have with the 10. Whether it be training it on it or training it on a GPU and then doing the quantization to convert it from like 32 or 64 float to a 4 int, which is what the processor is capable of handling. And that's the main difference between what the actual models that are capable of running on the Halo that they provide versus like the run-of-the-mill models that, you know, you would just download normally from like Ollama. So what time is it there? It's 3:21 here. So I'm in Eastern time. So thanks for staying up, Bruce Berry. So it's definitely one of those things where it's you know, the AI on the edge, I think, is kind of the future. It's going to be something where, you know, you can build data centers all you want, but if the internet goes down, it doesn't do a whole lot for you. So especially in the Homelab, not having to pay subscriptions and being able to do whatever you want, I think makes your Homelab that much more powerful. And especially if you want your, you know, whatever your home assistant is or anything else like that to talk or give you any kind of voice interface that's natural sounding, I think it's the way to go. So only a few more percent here and it'll be all ready to go, and then we can start the installation and go through exactly what we're doing. So to kind of give you a preview, we are using the Open Web UI, and that's going to be doing our front end, which will be accessible over the web interface, over any web browser that can access the Pi. And we're not going to go into firewall or security or anything like that. That's just out of scope for this. But we are going to just cover how to get it set up. We're going to be installing a Docker that has it pre-configured, and should be a pretty robust setup right off the bat, and then creating some service scripts to be able to run everything on boot. So as soon as you boot up your Pi, you'll be ready to go. Speaking of ready to go, there it is. I want local AI, so I'm interested in the test runs, and I definitely appreciate that. So we're going to keep pushing forward into it. So now that it's done compiling, let's go ahead and move the files to the runtime locations. I'm going to skip CDing to this directory just because we know I need to correct that, and I'll upload that after this stream is done. But we're going to make a directory which is inside of the home directory .local bin, and we're going to copy the from what we just compiled to that folder. Okay, so it did that. Next, we're going to do the config files. And this will tell us what models we have available, things like that. Same deal with that. Paste that in. And next, we're actually going to move the models to a place that it can find them. So we're going to create another .local folder and put them into there. Okay. Now, I will tell you, the reason that it was so fast in terms of copying those models is it doesn't have any of them downloaded yet. So the base repository does not have, or the base GitHub repository doesn't have anything by default, but it does have ways to get it, and we'll go through that in a second as well. So next thing we're going to do is we're going to export that path, the .local/bin, into our path variable to be able to execute applications from it. All right, and now we can start the Halo server. So first we're going to run it locally before we start trying to make it a service. Let's make sure it actually does something. So I'm going to right click here, paste it, and we see the server is running. It started successfully and it's running on port 8000 locally. It's not going to do a whole lot because we don't have a UI connected to it. And there are ways that we can use curl to be able to interface with it, but then we're writing JSON manually, which is not really the best, option in terms of ergonomics. So I'm going to Control-C to get out of that. And let's go ahead to the next step, which is installing the front end. So first thing we got to do is install Docker. So we're going to curl the script using the official download method. We could install it using apt, but this pretty much does the same exact thing. I mean, you see it's using apt-get. So we're going to let it do its thing. It's going to install it through the preferred mechanism, and it's going to be the most up-to-date version. And it's going to set a bunch of other variables, everything else like that, to make sure it's all good to go. And there it is. And one of the things that it will say is that you need to do a non-privileged user. So we can go ahead and do that as well. So let's set up Docker for our current user. It will still run as root because we're not running this command, but again, you already have physical access to it and everything else. So it's not going to be the kind of thing you want to be public facing. And then Docker and Halo server. So we're actually going to run our Docker right now. And then we're going to start Hailo-10H, which is the service we were just running a second ago. So we'll paste this in, it will start the Docker, and then run Hailo-10H immediately after. Permission denied for Docker sock. Oh, that's not helpful. Stop out of there. We need to start Docker. And we could just reboot as well. But we'll do start docker.service control. Let's see if we can do it now. We have to do sudo. All right, so it's going to pull the image. And one of the things that's good with the script is when you run it as a service, you can actually change what user it's registered under. I do have a sed command that currently populates whatever user you're currently using. And we'll go over that when we install the service and everything else like that. So it just kind of pre-populates it because really, I get a little antsy when there's a web interface out there that runs something as root, just because it seems like it's prime for exploit. But again, there's no reason you couldn't. And one of the models that's available is good for coding and things like that. So this does actually work for being able to help with that. So, something nice. So we'll go back now that we have it running, and we can confirm that by doing sudo docker ps, and we do see it's up for 18 seconds. Amazing. So now we're going to run Hailo-10H, which again is the service that it's going to connect to. Right? You're very meowy today. What are you doing? Okay, so now our service is running. So we have all of our configuration needed. So now we can go to 127.0.0.1, which is localhost, and do port 8080. and that's the default port. You can always map it to a different port if you don't like that port, but we didn't map it, so that's the port that it's going to. All right, so we're going to hit Get Started, and we're going to do some quick configuration on this. So we need to set a default user. Even though it's asking for your email, it doesn't actually leave this box. It is local to this box. So it doesn't actually care if it's a real email or not. It's not going to verify it. So we'll call this Extended Greg. The email will be Extended Greg. And the email will be your login. So, and actually, I don't know if that's a real domain. So I'm going to say extendedgreg.com. I'm going to give it a really secure password. I'm going to do create admin account. And one of the nice things about this is it does have a way to do access control. So you can assign different access levels, things like that, for who can do what. So now we have our traditional prompt. It says hello, has some ideas, but we look up here in the top left where we can choose our model, and there's no models. That's actually expected, just based on my experience. I don't know why it doesn't pre-populate with models and do all of that. We see that it keeps trying to list all of them, right? And we see those options are DeepSeek, Llama, and 3 different versions of Qwen. So take that as you will. And at the end of the day, if we go back over to the GitHub and keep following the instructions, we can install some of these models. So next, if we want to see that same list in the command line, we could do a curl. And this will do one of those backend commands to it as well. So we can open up another terminal, minimize this, paste in our command here, and we can see it gives us DeepSeek, the same exact list that we just got otherwise. So what we can do here is there's another curl command, and this will tell it to pull that particular model locally. And again, we're kind of creating this JSON command for curl to be able to do it. We just have to replace the one piece of text at the end, which is, I was going to say, where's my mouse? We are going to delete all of this inside of the quotes. We're going to copy one of these. And I will tell you this, for some reason, Llama is messed up. And I'll show you that as well. But we'll pull first the Qwen 2.5 1.5b, copy it, paste it, and that is the end. I don't know why it has extra text there. It shifted around. I probably should have hit enter first, but that's all right. It should still work. So I'm going to hit enter. And we see it's currently pulling down that particular model. And these models can still be pretty big. So if we do actually give it a second, it tells you how many bytes. It takes quite a while, but again, it's just doing its thing. It's downloading. And we can repeat this for each model that we want to download. So I don't know what the limit is. I mean, really, it should be determined by your hard drive space. So big thing is it says success. So now we know that it finished. We're going to leave it at just that one model for now. Right, so I gave that same example here. And technically it's supposed to show up here if we just refresh. Oh, and it does. But if it doesn't, you can reboot. So I'm going to skip that reboot because it is showing up. Sometimes it doesn't show up. I don't know why it does that. But again, it is here. So let's have it tell us a fun fact about the Roman Empire. And something you'll notice is that the actual output rate is a lot faster than trying to do this through CPU only. Perfect. That's very informative. So, again, it was one of the suggested things, and it doesn't know anything about it. I don't know where they make it, but so we could say, show me an interesting coding tip. And honestly, maybe Quen coding would be better for this, but let's see what it does. And again, it's loading it all up. I said I would do top for you. And if we look at top itself, outside of Chrome eating up all our CPU, you know what isn't eating the CPU is the language model. So we're still very low utilization, and there actually probably is a better way to look at this. Let's do resource monitor. Right, it shows up, I don't believe that the GPU is actually this. So let's see. Right, so it gave us a nice little do something else. That's amazing. Can you show me another tip? All right, so now it's going. We're going to watch it. Again, CPU is not moving at all. The thing that's really consuming it is Chromium. But it's still generating this content dynamically. I could feel there's a bit of heat. You know, it's definitely getting hotter on the actual Hailo-10 itself on the heatsink. But no real utilization, you know, in terms of the standard system resources. And that's beneficial, especially if you're looking at it through a different machine, to be able to have it act as a server. So now we've seen it actually do some things, right? And this is running locally. It's not going to another machine. We can go back to here and let's get it to actually install on boot. And the way that we're going to do that is, first thing, we're going to install dependencies. Technically, we did this already, which is to install Git as part of the previous thing. So I'm going to go over here. I'm going to paste this. It's already there. So now we're going to cd to the root directory, and we're going to download the extended greg Raspberry Pi Hailo-10 Git. And really, there's just 2 files in there plus the README. So we'll paste it, and then we cd into it, and this time I actually got it right, and into the root directory. And the root directory is just relative to the root. If we ls it, we see it's got etc and user. It's just all their relative, so you know where it's going to go in case you want to install it manually. But I do have the steps here for how to copy it directly. Yeah, and it's definitely, Bruceberry, definitely it's a lot faster than the CPU. I mean, just versus anything, I was actually pleasantly surprised when I was first getting it up and running, how fast it actually was. That, you know, I mean, outside of considering that the models that we're trying to run here are, I would say, modest, just being the 1.5 billion, you know, the 1.5B, versus doing like one of the larger models, I think it is quite capable, and it's very usable in terms of helping for assistance coding, coming up with anything else like that. 40 tops actually is a lot of horsepower. So let's see. So we're going to copy the scripts that we just downloaded. So we're going to start with the server launch script. So we'll paste this code, which is just going to copy it into user local bin, which is where we're going to put these executables. And then we're going to chmod it so it's executable. And next we're going to do the systemd script. And I already see a typo here. So let me do this. But I know, I'll tell you what the typo is. I'm going to fix that as well. So we'll do the first thing, which is just copy it to the systemd system folder in etc. And then we'll chmod it so it's executable as well. But the thing that we actually need to do with it is we need to set a username into it as well. And this, I could tell you, is wrong. So I'm just going to copy part of it. So two things on this. First thing is we need to escape user. Otherwise, it will think that it's doing one for each letter, and it will paste the user name 4 times. And then the second thing is, because we're doing -i, we actually have to put the file name, and the file name happens to be the service path. So we'll copy this, we'll paste it, and I will update that after the stream. All right, so now if we do cat and paste this again to be able to look at it, we do see here it says user dev, which is the user that we created. And pretty much it's just calling the script that we copied first, and it has a start and it has a stop. And if we look at the script itself, so user local bin, and to be honest with you, it's going to be the only script in there, which is Halo server. I'm just going to make this full screen just so we can see it a little bit easier. But what it's going to do is it's going to run the Docker. Ignore this stuff right here. I'm going to come back to that. But it's going to run the Docker same way we did before. Okay, but it's going to make sure that it doesn't output anything just in case it's already been run once before. Then it will just start it. Otherwise, it'll throw an error. So we suppress that error. Then we do Halo monitor, which is not something I've gotten to work yet, but is supposed to be something that you're capable of doing to be able to monitor the current statistics. But again, that's for another day. Then we do the same thing that we did before by adding the .local/bin to the path variable, so that way it's able to find the executable. I do create a log folder to be able to do logging of the output. I was going to do screen to be able to actually view the output in real time, but to be honest, for security reasons and also for diagnostic reasons, it's actually pretty nice to have it logging to a file. And that being said, if you're running this for a long time and using it a lot, you just got to be careful it's not filling up your drive. I do have an echo message here, right? So it'll output it to that log file with the date timestamp and just saying that it's starting. And then it runs Halo Olama and outputs everything to that log file as well. When it stops, that stop command, so pretty much you can put anything as that first argument and it will stop it. So it'll stop the Docker. And I have this here, but that's not really a thing, so it'll just do nothing. I probably need to clean that up, but that's okay. And then I have it add stopping server to the log file as well. So that way you could tell when things are happening, and then it just exits. So I probably could have done that with traps, but originally I was going to do it with screen, and I've had a lot of issues for some reason as well trying to catch traps through screen. It just seems to skip them sometimes when it's run through services. So no idea why, but this kind of sidesteps that by not even using it. So we have both of the files now on the machine and installed in the right location. So next thing that we can do is we can enable the service. This will make it start on the next boot. Okay, so it creates a symlink. And then the next thing we can do is start it as well. We currently have it running, so we're going to exit out of this. And I'm actually going to just close out that image for Docker. So I'm going to do docker stop open web UI with the sudo. Perfect. So now we can run this other start command. Okay, it said nothing, which is good. We can go to status. And we do see it is active and running and shows us a few things. It wants to create another log file, which is a permissions thing. We could do that too, but we have our own log file, so meh. So at the end of the day, it's still going to work just fine. And we can actually go down here. And I do have a couple of things, including how to update it if I do update the repository. But I also have some ways to monitor it down here. So one of the ways that we just did was status, and then we have tail down here. So we can actually tail the logs while we're using it. And it will show us what it's actually doing. And we see it's running. So now we'll go back over to here. We can refresh this, right? We still see Quen is there. And let's start a new chat, right? And we'll say, tell me a story. A story. Let's see what it does. Right, so I go over here, and you can see user says, tell me a story, right? IM end, and then the assistant is writing. So right here, I'm going to try and get out of the way. Right, so it says, you see it's loading the model initially. It says, I'm sorry, but I can't generate a story as I'm not trained in narrative writing. My purpose is to assist with tasks such as answering questions or providing information or specific subjects. And we see that that's the same exact thing that's here. So let's think of a good question, and actually it should give us tips. And may or may not do that. Let's open a new chat. Show me a code snippet. And again, it really is good at coding. So, I mean, that's one of the best things I find about AI is just it's really good at that. And some of the models have better functionality at certain things than others. We see here, it's trying to load up that model really quick. Should be working. Unless I broke it. Yeah, so it's doing things. I'm just not patient enough. That's an interesting one. What story would you like to tell me? So let's ask it that. Before I do that, though, I'm going to reboot. And I'll tell you why, because if it acts weird, just reboot it. So it's acting weird where it's a little bit slow. So reboot fixes everything. It should automatically start when it comes back up. And then we will ask it, what story would you like to tell me? Well, let's see what it says. Okay, localhost, we got to give it a minute to start up. Okay. Let's see what it says. Ooh. Get rid of the cat cam, unfortunately. So it doesn't have any preferences, but you know what? That's still a pretty good answer. And again, we'll do tail var log Halo server.log, and we can see that that's its response right here. Let's see, what's a good follow-up? There we go. You just have to act like you're thinking about it, and it will give you some options. Is there anything in particular you'd like to focus on? Let's see. It's just going to keep parrying the, avoiding the question. Right? So you see it pretty much prints it out as soon as it's done. Otherwise, it can give you the word for word kind of thing, which is how it's printing. So questions, let's see. What's another question we can ask it? All right, so how long has the International Space Station been in flight? And what was the process for how it was launched? See, and once it's loaded, it's pretty quick, right? International Space Station over 16 years. Technically, I think it was, what was it, 2000 something? Maybe it means when it was completed. I don't know. So that's pretty much what we're looking at with the 10H. And I think it's still very usable, and I like the UI because you can access it from any other machine, anything else like that. And Bruce Berry, I'm happy to play along. I'm just happy you were joining the stream and participating as part of this. It definitely helps you know, tune it to what you want to see. So I'm happy about that. So, but I'm happy for everybody who was able to join today, and especially those who were commenting in chat, anything else like that. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.